Hi guys, this is a tutorial of how to perform chi-square tests in SPSS, and in this video I will explain to you how to set up data sets for this kind of tests. There are two different ways of setting up the same kind of data, and we can run the same tests using both of those types of data sets. It works exactly the same way. It's just a case of preference essentially, or also sometimes the structure of your data that either allows you to use one type or the other. And then there are two different types of chi-square tests that we will also cover today. We will be using quite a simple example of data. Here we have data on 13 people, and we know about them, their eye color as well as their sex. So as always, we have people represented by rows in this kind of data set, and then each variable is represented in a column. We know that there are three different eye colors and two sexes in this case, and this is set up if you go to your variable view, so that we have three categories. One means green, two means blue, three means dark, and then we have male and female set up in the sex variable. Both of these are nominal because they are categories and there is no hierarchy between them. Okay, so very simple data set. We can toggle between the labels and the values here in our different data. Okay, so this kind of data, this kind of categorical or nominal data can either be set up like this, and this is sort of the raw data if you want, where each subject is represented by a line. Now if you had asked more than 13 people, let's say you did a large scale study and you had asked 130 people, you would need 130 rows of data. And sometimes when you have these really large data sets, it's actually easier to set the data set up in a frequency table. You can essentially summarize the data in advance, and then instead of putting a row, of creating one row per person, you just basically say, these are the different categories I have, and this is how many times each of those occurred. Okay, and I've got that prepared here. This is the other way of setting up this kind of data. Now, when you have not just one, but two variables about each person, it needs to be set up so that basically you have all the combinations between these categories represented. Okay, even if they didn't occur, in that case they just get a frequency of 0. They all have to be present. So since we have two sexes and then three eye colors, we essentially need female 3 times. Within female we have green, blue and dark eye color, and then the same for male. Okay, so within 3 rows for the male we have green, blue and dark eye color. And for all of these combinations, females with green eyes, females with blue eyes, females with dark eyes, males with green eyes, etc. We have the frequencies here. Okay, so we could have prepared that previously, and whether you have 13 people in there or 130, this data set would always look like this. You would just have different frequencies here. Now I will show you how to run chi-square tests on both of these different types of data sets, and there are two different types of chi-square tests that we can run. Okay, so I will go back to the original, the raw data, and start with that. The first thing that we might be interested in when we have this kind of data is whether in a category like this or in a variable like this, like eye color, is any one of these eye colors more common than the others. Okay, there can be eye color, it can be colors of flowers, it can be types of dogs, any sort of nominal variables that we've collected like this. We might be interested to see whether one of them occurred more often than the others. And that we can analyze using a chi-squared goodness of fit test. Now you might recognize that if I say one of these categories occurred more often than any of the others, this is what we describe as the mode of the data. We can quite easily calculate the mode of something like this, and we can look which one is the most common type essentially. But what this test shows us is whether that type, whether that be green or blue or dark eyes, is significantly more common than the others. Okay, so even if it occurred, let's say, 2 more times than green, that doesn't necessarily mean that it is significantly more common than the others. And that's what the chi-squared goodness of fit test tells us. Okay, in order to run this test, on, let's say, eye color, when we have our raw data where each person is or each subject is represented by a row, we go into Analyze, Non-Parametric Tests, Legacy Dialogues, chi-square. This is the window that opens up. Now the test variable, the one that we're interested in this case, is eye color. And what we want to compare that to is essentially a situation where all categories are equal. Chi-square tests always compare what you've observed, how many times each category occurred in your observations, to a distribution of some sort. So a distribution always describes how many times something happened. And in this case, we want to know whether one of these eye colors is more common than the others, or, and that is your null hypothesis, whether they were all equally common. Okay, and that is essentially what you're comparing your data to, a situation where all the categories are equal, and that's why this is selected down here. Okay, so you're basically comparing what you've observed versus the case that you would expect if none of these categories was more common than the others. Once you've put your test variable in here, all you need to do is press OK, and it will throw you out a result. That, as always, will come up in your output window, so we'll find that. First of all, what we get is a frequency table here, okay? So we obviously haven't created one, but this basically gives us that frequency table. We know that green eyes occurred 4 times, blue eyes 3 times, and dark eyes 6 times. Now what we would expect if all of them were equally common would be that each of them occurred 4.3 times. And that is because we have 13 subjects and we have 3 categories. If you divide 13 by 3, you get 4.3. That's your expected. Now, as to the question of whether one of these is more common than the rest, if you look at the frequency table, you can see that the mode in this case would be dark, okay? Most people have dark eyes, but is this significantly more common than green and blue? And this is the output that tells you that. You get your test statistic, you get your degrees of freedom, and you get your p-value. P-value here is what we're particularly interested in, and it is 0.584. Now that value is higher than 0.05, which means in this case, and in all cases of inferential statistics, that we have to accept the null hypothesis, which says there is no difference between what you have observed and what you would expect if all of the categories were equally common. So no, dark eyes are actually not significantly more common than any of the other eye colors. That is the result of this test. Okay, one other thing briefly to mention here is that you get a warning down here which says that some of the cells, 3 in this case, have expected frequencies of less than 5. Okay, the way that these are calculated, as I said, is the number of categories and you divide the total by that number. And if you have a very small sample size, like in this case, and you have 3 categories, that means you get an expected value here of less than 5. And that makes this test not very reliable. Okay, basically it's saying I don't have enough data to judge this by. The only way to get around this, or the only way that you can, the best way that you can rectify this problem is by increasing your sample size. So you would need to collect more data and ask more people about their eye color and what sex they are. Okay, we'll find out. Now, as I said previously, you can run this test using this kind of raw data, but you can also run it on something like a frequency table as you would have created here. Okay, so when you'd set your data up this way, you can do exactly the same thing. There's just one step first, which is to tell SPSS, okay, I've got these categories here. I've got 3 categories of eye color, green, blue, and dark, and you need to just basically associate these frequencies, link them to these categories and tell SPSS, okay, this occurred 3 times, and then down here again once. This occurred no times here, but then down here it occurred 3 times. So you need to link these together. They're not automatically linked, but it's just a real quick thing, a quick step, and it's in data, weight cases. You essentially give these categories a weighting, a frequency. Okay. So we assign the frequencies to the cases of eye color, and the frequencies are obviously in the variable frequency. So usually the default is do not weight cases, and in this case we do. We weight these cases by frequency. That's all we need to do. We just press OK, and now these are linked. SPSS now knows how many times each of these categories occurred. And now we just run the test exactly the same way that we did before. Non-parametric tests, legacy dialogues, chi-square. We put eye-color into the test variables. We expect that they're all equal, or we test against the expected that they're all equal. We press OK, and we get exactly the same result as we did before. Okay, so this just as to the two different ways of running a chi-squared goodness of fit test on raw data as well as frequency tables. And in the next video, I will show you how to run the other type of chi-square test, which we call a chi-square test of association, for which you need two variables for each person and not just one.